All right? Shh. Quiet, please. I'm hearing different answers, and I'm also hearing different approaches, which is fine. Let's take a look at how this worked. What I was trying to hint at is we could use this equation by replacing S with 400. This is one way to find the answer. Okay? What's negative 1/2 of 400? Well, first of all, what's 1/2 of 400? So A equals negative 200 plus 300. What's negative 200 plus 300?
400.
Negative 200 plus A equals 100. Okay, now other people did it different ways. Other people did it different ways. If you have another way to look at the problem, what do you have?
I did wrong, so.
It's all right. If you got to this 100, but you have your way, that's okay. They were trying to show us how to kind of use this type of an equation to help out. Okay? All right, number 6. Can you use the graph to determine how much money is collected if the athletic association sold 400 students and 200 tickets? So we're trying to find money. Let's look at that graph. Does it tell us anything about money?
No. Actually, it
Does it? This is adult tickets. This is student tickets. Do we see money anywhere?
No.
No. This graph only talks about numbers of tickets, so no. Okay, we can tell numbers of tickets and we can compare adults and students and find combinations, but we don't know money off of this graph. Camel, write down no for number 6. Flip the page. Andy, could you read number 7 for us, please?
Yes, let's consider reaching the $3,000 goal for tickets sales by analyzing the number of adult tickets sold. If the association knows that 150 adult tickets have been sold, how many student tickets will they need to sell to reach their goal?
Okay, so this time we know 150 adult tickets. Put a box around the number of adult tickets, please. Same goal,
We need to sell 300 students.
but adult tickets. Transform the equation is our first task. The last time they transformed the equation, what letter did they get by itself? A. This time we know A, so what letter do we want to get by itself? S. So we'll start with the original equation. Please write this down. We want to get S by itself, so this time I'm going to subtract the A. I get 5S equals. These two terms, even though I wrote this right underneath, they're unlike terms, so I can't actually subtract that 10. The way I write it is minus 10A plus 3,000. I have to write it as two separate things because one has an A and one doesn't. What's my last step to get S all by itself?
Divide by 5.
All the way across. Divide by 5 every single term in the equation. This is going to get us S equals 10 divided by 5 is, but it was a negative, so negative 2A plus 3,000 divided by 5. 600. Oops, stop there, 2 zeros. All right, so we've transformed the equation because I already know about adults. This time they're going to ask me a couple questions about students. Okay, how many student tickets must the Athletic Association sell on homecoming to reach their goal of 3,000? Using the 150 adults and using this equation, please figure out how many student tickets they must sell. I'm going to move around the room. Adults.
300.
What do we need for students? Okay. Make sure you're focusing. You're focusing a little scattered today.
That's easy to open up.
Okay, we're right here. We're in B, guys. We have 150 adults. How many students? One thing you may lose is this, but you don't have the whole equation written down. 150 adults. The other piece of information. This is your equation, and you also know 150 plus your adults.
I have to tell you this.
Okay, this is your equation, you also know 150 adults. Yes. Got it over here.
Is that a shirt you wear?
Okay, take this equation carefully. There you go. Good. Come on, here's your equation, but you also know there's 150 adults. That's what A is in this situation. Can we go? Students equals -2. How many adults? 150. Replacing the A. S equals 2 times 150 is 300, but it's a -2. S equals 300. C. Jerry, could you read C for us?
Determine the x-intercept and the y-intercept of the graph described by this equation. Explain what the intercepts mean in the terms of the problem situation.
Alright, so let's go ahead to this equation and look at the equation, because one thing we're pretty good at is y-intercepts. Where in that equation is the y-intercept? Okay, y-intercept is 600. Okay, but look at what this guy is saying over here in our little box. Remember to what? Last time they labeled it for us.
Label your access.
This time we gotta label it. But wait a minute. What do we have right here? What letter is that? A. And what axis or what letter is usually right there? If say that's usually the spot of X. So this time X is going to be our adults.
adults.
And y is going to be our students.
Sure.
So it's a slightly different graph than we were looking at last time. Because of the way the position of the variable, you usually put the independent variable, Jerry, right here, or the x-axis variable right here. You usually put whatever's over here, students, is your y. So our y-intercept is 600. That's on the student axis. That's right here. 600. Ding, 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 ding. Put a dot.
Yeah.
I have -2 for a slope. I'm going to put that -2 over 1 because I know how to use a slope to sketch a line. That means go down 2 over 1. Down 2 over 1. Sketch a line carefully. Again, this 600 is y-intercept.
Yeah.
Y-intercept is 600 students. One of the things that we need to find is x-intercept.
Which would be about approximately
What's it looking like on your graph?
326.7.
300. But what does the y-axis represent? Adults. Okay, so x-intercept is where does it cross the x-axis, and it depends on how well you drew your line. We're going to have to look at this some more next week because we're time. Hey, I need calculators and rulers and books. Should I put everything over there?